Augmented reality, a disruptive technology. Imagine having the power to understand any sign or text in a foreign country. Or being able to see and decide from all the possible restaurants around you by only using your phone, with the menu information and reviews from other users at your hands. This is the magic of the augmented reality. Augmented reality is an interactive experience of a real-world environment where the objects that reside in the real world are enhanced by computer-generated information. This technology consists on the creation of a situation in which virtual information and objects merge with reality. This offers the user an enriched experience without interfering with the natural perception. AR can be used to expand our senses, defining a direct or indirect vision of a physical environment of the real world, whose elements are combined with virtual items such as texts, images, audio, videos, or even 2D or 3D objects, for the creation of mixed reality on real time. Depending on the level of interaction, AR can be categorized as mixed reality. The first widely known augmented reality device was created in the late 60s by Ivan Sutherland, developing the first head-mounted display with generated computer graphics, the Sword of Damocles. Although it was a pretty big and fixed device, it was able to draw wireframes drawn on a secondary computer screen. The current state of AR is far past this device. With the introduction of smartphones with access to GPS and accelerometers, there is now enough portable hardware available to create AR applications based on the physical movement of the user and image processing. In 2003, Adrian David Cheok presented the Human Pac-Man, a game that uses GPS and accelerometers to determine where the objects have to be placed to be eaten by the user, who acts as the Human Pac-Man. These technologies were also introduced in other areas, such as with vehicles with head-up displays, HUDs, projected on the front windshield indicating the route, speed, GPS directions, traffic signals, and lanes detection. AR technology highly relies on image processing or computer vision, and also in the user's position detection using GPS and accelerometers. Computer vision has evolved, taking giant steps from over a decade ago because of the implementation of artificial neural networks. This is a technology that stimulates the human brain to capture information of different sources like images. With that visual information and artificial intelligence technology, the device is able to recognize the object that the camera is focusing on, making it possible to place virtual objects at specific places on the screen. This artificial intelligence system is a complex software design that was previously trained with different images of the objects that the designers wanted to recognize, with each layer of the ANN network processing different parts of the image. The first layers capture abstract figures from the image, like the curvature of the different car parts, colors, badges, or proportions, and each layer almost specializes in one of these. The final layers evaluate the characteristics found and generate a probability for each type of possible output. For example, car, truck, van, bicycle, etc. Each of the neurons represented as blocks on the illustration have a specific weight that is configured during the training step of the ANN network. The training process is easy to understand. It consists of 3 steps. The first one is feeding an image to the ANN system. The system will analyze what is found in the image and respond with a category which has the biggest probability from all the other possible categories. Then, the second step consists on calculating the error generated if the wrong category is decided by the system, with a specific mathematical formula depending on the optimizer algorithm. The final step is to update the weights of each of the neurons, represented as balls on the illustration, with a small value generating a new weight conditioned by the previous one and the error found on the second step. With this ability, AR-based applications are able to identify objects at their current environment, and since the device is connected online, it can search and download information of these objects, summarize and process it, and make it available to the user almost in real time. The AR-based system is being implemented widely in almost all fields, having an especially notable impact on medical applications, where, for example, MRI and TAC images are superimposed over the patient's body to make it easier to locate the surgery points. There is no doubt that AR is a technology that will have a big impact on our day-to-day life in the future. It will provide information about virtually everything that we can see.